In lesson 34, we're looking at another form of uniform motion problems. This time we have a distance added to another amount to equal another distance. In our first example, we have Millicent began the journey at 6 a.m. at 50 kilometers per hour. Then Beauregard began to chase her at 10 a.m. at 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Millicent? So, if we think about when they're starting, so Millicent had already started, and then Beauregard was chasing after her, and then we're wanting to know when he had gotten within 40 kilometers. Okay? So Millicent started at 6 a.m. Beauregard started at 10 a.m. and Millicent is traveling at 50 kilometers per hour. And Beauregard is traveling at 60 kilometers per hour. Okay, and as far as their times go, we know that Millicent has 4 hours more than Beauregard. So her time will be t plus 4, and Beauregard's time would be just t. And the reason I assigned t to Beauregard is because it says what time was it when Beauregard got within 40 kilometers of Millicent. So I'll be adding that time to his 10 a.m. start. So if I set this up, just looking at what would make these two distances equal, I'd have 50 times t plus 4. That would equal 60 times t plus that 40 kilometer distance that Beauregard is within reach of Millicent. And this is what I would solve to get the actual hours of time, but it actually asks what time it is. So once I get the hours, I'll just count from 10 a.m. to find out exactly what time that would be. So I'll distribute the 50 across. So I'll have 50t plus 200 equals 60t plus 40. Now I'm going to get my t's on one side, so I'll subtract the 50t to move it to the right side, and then I'll subtract the 40 to move it to the other side. So I'll have 10t equals 160, and I'll divide both by 10. So it'd be 16 hours from 10 a.m. So I know that from 10 a.m. to 10 p.m. that's 12 hours. And then I'd have 11 o'clock, 12 o'clock, 1 o'clock, and 2 o'clock. So it'd be 2 o'clock in the morning when Beauregard is within 40 kilometers of Millicent. In the second example, we have the sheriff chasing Robin Hood. The sheriff began his pursuit, and Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour, while Robin Hood's rate was 2.5 miles per hour, how long did it take the sheriff to catch up? So again, if we draw a picture, it kind of helps us out. So Robin Hood is already 7 miles ahead of the sheriff when the sheriff starts. Okay, so this up here would be Robin Hood, and the bottom would be the sheriff. And Robin Hood is traveling at 2.5 miles per hour. And the sheriff is traveling at 6 miles per hour. And their times will be the same because it had said when the sheriff began his pursuit that Robin Hood was already 7 miles ahead. So they both just have a time of t. So when I set this up, I'll have 7 plus 2.5 t, because rate times time, the distance here, will be equal to the 6 miles per hour times the time. Okay, then I'll get my times together. It'll be 3.5 t equals 7, and I'll divide both sides by 3.5. So the time is 2 hours. So it took the sheriff 2 hours to catch up with Robin Hood.